In this session, we'll be looking at an example of how to create superalignment geometry from a non-3D source. I'll be using the intersection point method for constructing the geometry and show you some techniques for making this process a little easier. Hello, my name is Rod Burns. I work for Extra Dimension Solutions and I'm one of the 12D model trainers and technical support staff. So for some background on the superalignment, sometimes represented as SA on the 12D forum and menus, this is the only string type to contain complex elements for both horizontal and vertical geometry. In the horizontal, I'm referring to possible requirements for transition spirals, and vertically, it's the only string type to contain parabolas. So it does make this string a little unique. The geometry needs to be designed separately, and these parts are essentially linked together using the chainage as it's designed. The geometry can be defined by various methods. The intersection point method, where we're going to go through now, where the bearings and straights of the horizontal and vertical grades intersect. There's also the parametric design or element method, where the geometry can be built, often referred to this as a Lego box, where we can actually place a number of parts together. There's quite a number of choices, but you do find you use the same ones quite often, so don't be overwhelmed by the number of choices that you have available to you. Or a third option is actually to mix the two, both the intersection point and the element method together. Again, it's a little bit more advanced, but it's quite possible to do such. Given the complex mathematics which might be involved in the geometry of your superalignment string, 12D model have specific superalignment tools for manipulating and editing these string types. These can be found off the main menu as shown, or you might prefer to use some of the superalignment toolbars that have also been developed. Okay, so now that we've finished with the background of the superalignment, let's jump into 12D model and put our intersection design together. So this example's come to us from Griffith City Council, so I thank them for that. Intersection upgrade, it's a pretty nice looking little roundabout there. And I wanted to concentrate on curve return number 1 here, the northeast. As you can see, the geometry, fairly few curves, back-to-back curves in there. And if I was building an element method, I would basically I'd break it down to the arcs and the lines and arc, and basically break it down into the actual individual elements, and then look at fix free, and actually building it up. But we're going to do this with IP method, just to show you can do it with IP method even when you have got this sort of intricate sort of geometry going on. So that's the horizontal, what we're aiming for. They have also produced a long section, and there's some horizontal geometry up the top here and some vertical geometry on the segments as well. So to get started, I'm actually going to zoom in a little bit here, look at the table here with the northings and eastings for the geometry. And I've already pre-prepared this. I've got a spreadsheet here running, and you can see what I've done is I've actually grabbed the information and I've sort of given it a name, or where the points were, where the start was. Not interested so much in the chainage, but grabbing the easting and the northing. And where there was an arc, the radius of the arc, 15, I've actually placed that in as the name also. So I've just given it some name for these geometrical points. These are all the tangent points, and I'm going to load these into 12D. So I've got this information in the spreadsheet. I'd save it as a CSV file so that I can then import the geometry points into 12D. So I'll just flick over to 12D. New 12D project, nothing's in here before. I'll just grab the toolbar for the super alignments. So that's SA all, and turn that one on. I'll place that one up the top there, because I'll be using that quite a bit. So to start off, I want to read in a file. So the file, because it's just a data XYZ file, I'm going to come to the XYZ and points file here. You can see I've already filled it out, I've cheated, but I've got the CSV file there, text, just putting it in the model called base as standard 12D. And the format is important, the fact that I've got the easting and the northing, and the name is in column number 1, comma delimiters, so I can hit read there, and there's the geometry itself. So that's the tangent points that have come in. So given that I need to form the IPs for the geometry itself, I brought the names in so that I can actually come over to the toggle and toggle on the string names. And you can see now it's got the radius in there for me, so I don't have to go back to the PDF or the spreadsheet. I'll know what I'll actually be trying to build up in here in terms of the geometry. So I want to build in here the arcs, and I want to do some drafting to find the IPs. So I'm going to keep it in the model called base, select a different color, and the tool I'm going to go and use just to draft these in is off the arcs, and it's the 5th one out here, 2 points and a radius. Or if you prefer, you can come through the main menu under CADs, arcs, and it's here as well, 2 points and radius. Down the bottom you can see it's saying select the first point, and then I enter in the radius. And again, I just thought it was a nice way to do it with the name, so you don't have to keep going back each time. Hit enter and you can see the radius there of 15. I finished on the last point and accept, and it's drafted my arc in. So I'm going to have to do that, go through all the arcs now and put those in. And we'll finish on the last one here with a radius of 15 to my end point. Excellent. So I've drawn in the geometry essentially what I wanted, but it would be a bit of a mistake at the moment if I actually just came and joined all the strings together, all those individual CAD strings, because I would actually have a vertice at the end of one arc and another vertice at the start of the other. So I don't want to do that. I actually now want to come in and start to create my super alignment. So just give it a name. And I'll place it into the same model just to show you there. Might pick a different color so it stands out. Chainage, start at 0, and I will put a label style on there so that if the geometry breaks, we can see how it actually gets formed, where the problems are. I'll do that on the right hand side, and we might go for a 10-meter interval. Transitions, it's a road, so I don't need to worry about anything there. And that's about it. So I can hit create. Get the editor up. And now I'm looking to put in the IPs. So I'm going to come to the first option here and append the horizontal intersection points. So I start here. Now that's really big on the screen. So while that's running, I'm just going to come up and change the settings for the view. We might change it down to say 200. And that's just changed the text size. And I now want to come through and find where the IP is. Again, I'm looking for the geometry here. So 12D actually does have a snap. It's the fourth one down in the list here, to snap to an IP. So as soon as I click on the arc that I've drafted in, hit accept, 12D will actually click it onto and snap on straight onto that arc there to where the IP point is. Now, because I've got a number of snaps to do, again, you might come back to the toolbar. They're in alphabetical order, so if you just click in there and hit S, it'll go down to the top of the S list, and I'm after the CAD points because I'm going to be using the CAD interval one quite a bit, so the snaps IP one quite a bit. So I'm going to go to this IP, around the corner again, to this IP, to this IP, this one, and finishing there. Escape. So there are all the IP points now locked in. I didn't have to worry about the straight. Obviously, I'm going to build it off the curves themselves. Now, because I've got the right number of curves in there, I can come back and I've got two choices. I can either come into the move edit, which is actually placing the curves on to the IP. So I can click on IP number 2 and type in the radius again, 15. Maybe 15 in there. And that obviously draws in the geometry correctly for me. Or I can actually come to the HIP editor, which is essentially like a spreadsheet table. If you are given the coordinates and the geometry in the spreadsheet, I could actually come in here with the IP points and actually copy and paste from Excel into these here. And I'll show you how to do that in with the vertical geometry. But for now, what I can do is come through and I can actually put all the radiuses in through the table here. I do need to change the IP number to place a curve on there. So clicking in the cell, right mouse button, and selecting a curve with a radius. Or again, if it's highlighted, you can go control copy and paste that into other cells as well. And then just simply come through and place the radiuses that you want. So what do we have here? -80. It's set, and that's drafted in the curve there. -20 here. Set that one. Negative 100. And the final one was negative 15. So that's all drawn that up correctly. The only one I've skipped, as you can see here in the list here, the only one I've skipped is where we have a radius of 37 in here. It was a small, very small radius that was in the drawing. Now, if I do put in the radius, you'll find, and I hit set, all the geometry disappears and I get an error at that point. Again, because 12D, I guess off the spreadsheet or off the drawing was only given 3 decimal places, it actually can't fit this curve in given those 3 coordinates, or given the coordinates to those 3 decimal places. So I just need to play around with this. I would suggest making it a little bit smaller. Hit set there. You can see all the geometries come back. But you do get these very small straights either side. 12D does have a tool under the superalignment editor as well for the tangent wizard. And this will make the arc as large as it can possibly be to fit into the space, into the length that it's provided there. So if I click on that and hit accept, you can see it's just made it slightly larger. If I came back to the table and showed you the answer here, we've now got 36.98. So yeah, not quite 37, but it's pretty close in there. So that's the large arc in there, and that's how we can create the horizontal geometry from the IP method. Let's now have a look at the vertical geometry for our example number 1. So I'm just going to quickly jump back to the long section view here. And as I said, some set out information was provided. You can see the vertical segments here with some heights and grades. But probably you would use the long section. I've got the information down the bottom here. Get that in here. And again, just to speed the process up, on the spreadsheet, you can see what I've done. I've actually gone through and counted how many IPs I need. So I've basically put in the chainage and the design height here, what the grade was, and if there is a vertical curve, what the length of the vertical curve is. So I essentially just went through the long section, had a look at those, because this long section is a little bit unusual. They've actually given us the chainage for the VIP, the vertical intersection point, but there's actually no RL or height there. So I've given a height, I could get the design height, but that wouldn't actually be the correct height for where the IP position would be, the intersection point of the 2 grades. So I've marked these ones as red, and I've just put a height that's fairly close to the height of the project, you can see, so that I'm not 100 meters off or anything like that. I'm fairly close, but those values in between, wherever these vertical curves are, as I slide this across a little bit, for the long section to all the vertical curves that I've got, the heights would be the height of the actual design. It wouldn't actually be the height of where the IPs are. But I do now know that I need 7 vertical intersection points based off that. So I'm going to jump straight into 12D and we're going to add those in. So I'm going to park these next to each other. Let's do that. Bring up my long section view, pull that across here. And hit profile my super alignment, come back to my long section view here. So there's all the horizontal geometry in there, and I can then start to put in the vertical geometry. So to speed this up a little bit, I'm going to come down to the second one down, just jump in here, and I know that I need 7 of them. So I'm just going to go to town 1, 2, 3, 4, 5, 6, and 7. Hit escape, and that's basically given me the 7 IP points that I need. Obviously they're not in the correct location, possibly not even at the correct height. But again, I can cheat a little bit, and you can do this with a horizontal if you're given the IP information. We can come straight into the editor now, and you can see, again, it's been set up in this sort of spreadsheet fashion. And it does help because I can then come across, grab the correct changes and heights, if I know what they are, come back into the spreadsheet here and paste those values in. Hitting set, obviously the vertical geometry is now updated. And I can do a zoom extents and take me directly to that location. So you can now see where we are in terms of the position of the IPs. Now the grades are not correct. And in this position here, I can't actually put the grades. So I'm going to come back into this one in a minute. I'm just going to fix the grades up and then come back and put in the vertical curves. So the grades are known. Again, I've put that off the long section. I've got that information for ourselves. So I'm going to come in and use one of the 12D tools. It's under the second one across where we can move or edit these IPs. And it's the second last one here, change a grade. It allows me to simply come and click on between 1 and 2, the grade that I want to change. It comes up with the current value, and I can then type in the value that I want. So I can just simply type in 2.546, enter, and that's now produced the grade that I've asked for. And I can just simply work down the list in this fashion now. So I just keep working along until I've done them all and I've locked them all in. Now, don't be too surprised by the 0.35 grade at Griffith. They're lucky if they've got half a percent or 0.2% in some places. Now you can see the last one has ended up being 2%, which is pretty close to the 2.08 that I was expecting. So those grades are now correct off the long section, and I can then come back into the table again, and I can start to input the curves. Well, again, you've got two choices. We could come back to the curve this way to put in the vertical curve length, select the IP and simply type it in, 8.193. Or we could come into the VIP properties, and you can see the length of the IP there. It's also set up to length already, so I can just simply copy from the spreadsheet again and paste those answers into the correct cells, hit set, and all those parabolas have now been added into our geometry as well. So that's a quick way to get the horizontal and the vertical geometry placed onto your project. Now that we do have the horizontal and vertical geometry on our string into 12D, I would suggest creating a quick plot just to check that the geometry is correct as per the PDF. So that's simply coming up to do a long section plot. I'd suggest using one out of the 12D library if you don't already have a standard one in the company. Hitting read, selecting our long section view, and it's then loaded in the name of our example. If you do know the scale, again off the sheet of the PDF, I would suggest you put it in a similar sort of scale. So on the PDF it was 1 to 300, 3 times exaggerated, or 1 to 100 on the vertical. A1 sheet, and I'm just going to plot it into the model called A1 example there. Tend to grab the whole name in case I want to do this again, pop it back over the top and hit write. And because I've only got the alignment string that I'm profiling, I do need to come under the boxes, under the tins, because I actually don't have a tin called survey in the project at all, and just disable it so it doesn't try to plot the tin for me as well. Hit plot, and that will be produced to my model. Coming back up the top here, you can see the model that it's gone into. Pop them over to the side for a second, bring up a new view, and I can then add on to my new plot. And I can then come back to the PDF and just check that the values are correct, just spot checking some of the changes across the alignment to make sure that I actually have inputted the correct geometry. And that's a quick one to do, just to check that you have actually entered everything correct. Thanks for your time. I hope you've enjoyed this, and we'll see you next time.